Hello everyone, welcome back to your favorite and India's most affordable learning platform, Physics Wala. So in the last session of simple harmonic motion, we discussed the concepts of finding the time period of any S.H.M. Alright, so today in continuation with the same chapter, that is simple harmonic motion, we are going to deal with the lecture number 5. So where in lecture number 5 we are going to focus on two important topics, that is the simple pendulum and the compound pendulum. So this, based on the simple pendulum, the questions were asked in the previous years like in JEE and NEET as well. So we'll discuss this topic in detail and we'll go for the compound pendulum, okay, and oscillation of a floating body also we'll see it in today's session. Okay, so as usual guys, I just need your attention for the next 1 hour. Just be with me, avoid all the disturbances around you for the next 1 hour, and at the end of the lecture it's very important to prepare your own short notes. Chalo, so let's get into the today's topic. So the first one, simple pendulum. So you all know that the simple pendulum, so here there will be some fixed end, the length of the string will be L, and there is a bob. So this is a bob of mass some small m. So actually the length of the pendulum is calculated from the fixed end to the center of the bob. So this whole length is a L. From here to the center of the bob, this whole length is L. Okay, and let the mass of the bob be m. So here we write, so m is a mass of the bob. M is a mass of the bob, and then L is the length of the string, or we can say the length of pendulum. Chal. So now here, how do we find the time period of the simple pendulum? To find the time period of any pendulum, so we have seen 3 steps. So not pendulum, any S.H.M. So what's a method? So first we have to find the equilibrium position where the net force acting on the body is 0, and then we just displace it by small displacement x from its mean position or equilibrium position. So then what we do? So we express the force acting on it when we displaced the force acting on it, so in the form of minus kx. So then the time period will be equals to t is equals to 2 pi into root over m by k, right? The same procedure we are going to follow for the simple pendulum as well. So what I am going to do is, let's displace this simple pendulum from its mean position by the small displacement, let it be theta. So this is the theta. So now it is displaced. Now what are the forces that are acting on it? What are the forces that are acting on the body? I can say that the mg force acts on the body like this. This is the equilibrium position where tension will be equals to mg. Now from the equilibrium position, displace it by slight displacement, let it be x. So then, so here the net force acting will be mg downward. So shall I write the components of that force? So if you extend this one, so I can write here, so this is theta, so this angle also will become theta, so that this side mg cos theta will come, and then the perpendicular, this is a mg sin theta, so mg sin theta, right? So and from here to here, so the length is L, the length of the string is L. Now see here, I could say that this is perpendicular one, the force is perpendicular to this line. So now what is the force acting on the body? The force is nothing but the C. So the force is equals to here mg sin theta. Which force causes the restoring force? Which force causes the body to come back to its mean position? Understand carefully. So this force, the mg cos theta, is not responsible for the restoring force. That means this will not bring the body to the mean position. So which force is responsible for bringing the body from here to the mean position? So obviously the mg sin theta is towards a mean position. So I represented the force which is responsible for bringing the body from some position to the mean position, so which is mg sin theta. So now let me do one thing. See, so let's say, so this is somewhat the angular one. So as we consider that displacement is small, so I can take this total distance as, let it be some x. Actually it should be like this. So here this is theta and then this is the length, so this is x I am taking. So this is somewhat curved part, as the displacement is very small, slightly displaced, so I can take this curved part as almost the straight line, let it be x. So this distance from here to here we consider it as x. So now f is equals to mg sin theta. So then I can write here f is equals to mg. So from this triangle you can see that, so sin theta is opposite by hypotenuse, so that is, so x by L, x by L. So now let me write this as mg by L into, so the displacement x. Understood this part? Now, so see, so as the displacement is right side and the restoring force is left side, the displacement is right side and the restoring force is left side. So then I can represent this force as F is equals to minus mg by L into x. We have to express the force that we got after displacing the body in the form of F is equals to minus kx, right? So that's what I did, because the displacement and force are in the opposite direction, I kept minus here. So I got it in the form of F is equals to minus kx. If you compare, so we have in place of k mg by L, in place of k we have got mg by L, not kl, mg by L. So now let me go further in the let me take the next slide. So once you got the k, so finding the time period is easy. So the time period of any pendulum is 2 pi into root over m by k. So t is equals to 2 pi into root over m by k. So what we got in the place of k? So the k is equals to here mg by L. K is equals to mg by L. So then substitute it here, mg by L. Done. Chal. So m cancel. So the time period is equals to 2 pi into, so this L will go up, so L by root over L by g. So this is a time period of the simple pendulum. So this formula already you know, but so how do we solve this? Already we learnt finding the time period of any S.H.M, not only this one, any S.H.M we know to find the time period. So now for the simple pendulum, so this is how we get the final formula. So this is a time period of a simple pendulum. Time period of a simple pendulum. Chal. So now one more thing here. If you observe, the time period is not dependent on the mass of the bob. Is there any mass term in this formula? The time period is depending on the length. So the time period is depending on the g value. So this g value can vary sometimes. Sir, g is 9.8 only, right? Yes. But so if the object is placed in an accelerated frame, so in place of g, the g effective will come into the role. So we have already discussed it in the Newton laws of motion. So here also we'll discuss. So first write the main point is the time period of a simple pendulum does not depend on the mass of the bob. So important point. So time period of a simple pendulum, the time period of a simple pendulum does not depend on mass of bob. It is independent of the mass of bob. Very important. Done. Chalo. So that's the first point. And the second very important point, that is the time period is directly proportional to root L. So the time period is directly proportional to root L. So we can write, so the T1 by T2 is equals to root over L1 by L2. So this is also one important point. Clear? Shall. So based on this, the questions can be framed. So let me take a simple question. So see, we know that the time period is directly proportional to root L. So the T1 by T2, I can write it as root over L1 by L2. Right? Chalo. So now let me take the simple question here. So consider the time period of a pendulum is 2 seconds. The time period of a pendulum is 2 seconds. If the length of pendulum increases by 4 times, so then find new time period. Hope you guys are solving already and you got the answer also, right? Simple question, right? So the original time period is 2 seconds when the length is L. So now when the length increased 4 times, so what I am doing is, so the original length of the pendulum L1 is equals to L2, let it be. So then the time period T1 is equals to, they said, 2 seconds. Now when the length increased 4 times of the original length, it increased 4 times. So what's the length has become? 4 times the original length, which is 4 times the L. So then what is the time period in this case? So you already know the concept. So the time period is directly proportional to root L. So the time period T1 by T2, so I can write it as, so the time period T1 by T2 is equals to root over L1 by L2. Done? Clear? Chal. So root over, what is L1? So L by L2. So what's the new length? 4L. So then T1 by T2 is equals to, L gets cancelled. So the T1 by T2 is equals to 1 by 2. So from here T2 will be equals to 2T1. So the T1 is already given 2 seconds. So then the new time period T2 will become 4 seconds. That's it. The new time period has become 4 times. Understood? Any doubts here? The simple concept. So and one more thing here you should understand. So the time period formula, we got it as 2 pi into root over L by G. So if there is some percentage increase in the length or some percentage increase in the G effective value, so then the time period changes. Yes. So let me explain it through the question. So or what is the change in the percentage of the time period that they might ask? So you can simply apply the error analysis. I'll take the question, just understand the concept first. I'll take the question. The error analysis method, if the change is very small, you can go for the error analysis method. Okay, so the delta T by T percentage will be equals, or else first let me write this way. So the T is equals to 2 pi into L by G whole to the power 1 by 2. So 2 pi into L by G whole to the power 1 by 2. So here the delta T by T percentage will be equals to error analysis method. So 2 pi is a constant. I can write 1 by 2 into delta L by L. Okay, in plus. So 1 by 2 into delta G by G. Delta G by G. Right? So in terms of percentage, if you need it. Done. Understood guys this part? So let me take the simple question based on this. Let's say if so the length of the pendulum increases by 1%, if the length of pendulum increases by 1%, then find the increase in time period. Find percentage of increase in time period. Find percentage of increase in time period. Clear? Chal. So hope you guys solved already. Easy one, right? You know what's the information given here? So if the length of the pendulum increases by 1%, so that means, so delta L by L percentage is given. So which is 1%. Done. So I need the percentage change in the time period. So the delta T by T percent is equals to delta L by L percentage into, sorry, plus 1 by 2 into delta L by L plus, so 1 by 2 into delta G by G. So the delta G by G you can consider it as 0. They did not talk about any G value change. So here directly I can write 1 by 2, so into how much is the percentage change? So which is 1. Chalo. So then the delta D T by T percent will be equals to 1 by 2 into 1. So which is nothing but 1 by 2 percentage. So that means 50%. So the 50% is a change in time period. Understood? Everyone? Clear? Chalo. So note this down. So just you have to understand this concept, because based on this the questions were asked in the previous years. Okay? Chalo. Now let's see the concept of G effective. See, in the time period formula of a simple pendulum, we know that this G is the acceleration due to gravity, right? When there is when the object is not in the accelerated frame, you have to take the G value as 9.8. But so let me consider this scenario. So let me explain with the examples. So here I am considering, so consider this is an elevator. So the case 1, consider this is an elevator where the pendulum is placed in it. Consider the pendulum is, we can't place it directly like this. So let's say, so the pendulum is hanged inside the elevator. So now let's say the elevator is going down with an acceleration A, or else let's say the elevator is going up with an acceleration A. Now the G value will change. How G value will change, sir? So because its weight is acting mg downward. If the object is inside the accelerated frame, so the new force that we consider as a pseudo force. What's a pseudo force? So the ma is a pseudo force. Now the net downward force, so the total force is downward, right? So the net downward force is equals to, the net downward force is equals to mg plus ma, mg plus ma. Now so what is the net downward force? So m into G effective. Now so which is equals to m into G plus a, I can take. So G m gets cancelled. So the G effective in this case will become, so G plus a, right? So actually in the time period formula, so we have to substitute 2 pi into root over L by G effective. So in this particular scenario, we got the G effective value as 2 pi into root over L by G effective as G plus a. So which means here the time period of the simple pendulum increases or decreases? Which term will decide? So the length is constant, 2 pi is constant. So G plus a. So this term actually increased from here to here, here to here. So the denominator term increased. So that overall time period decreases. The overall time period decreases. So that means this is a fast time. If the time period decreases means it's a fast time. Yes or no? So time gain takes place. Here we call the time gain takes place. Understood guys this part? So the concept of G effective. So let me consider another scenario. So where this is a let's say elevator. So now a simple pendulum is hanged from the, so this is of mass m. Now, so let's say the lift is accelerating downward. Previously I took downward, upward. So here it is downward. So then what are the forces that are acting? The mg is downward. So and then the pseudo force ma will be upward. So then I can write the net downward force. Net downward force is equals to, because still the downward force will be like, still the net force will be downward only. So I can write mg minus ma. Done. So here m into g effective is the net downward force. M, take it common. So here it is g minus a. M gets cancelled. So then the g effective will be equals to g minus a. Now I can write the time period as, so t is equals to 2 pi into root over L by g effective. Done, guys. So now here 2 pi into root over L by the g effective value is g minus a. So originally the time period has to be 2 pi into root over L by g, but here it is L by g minus a, which means the denominator term is decreasing. So if this decreases, time period increases. Here the time period increases, which means, so time loss takes place. Here time gain, right? So here slow time or time loss takes place. Loss in time. Done? Clear? Chal. So let me consider another scenario as well. If the same, let's say this is so here the pendulum is hanged from the mean inside the accelerated frame. If the acceleration is, let's say, right side, then what are the forces that are acting on the body now? The mg force will be acting downward, and then as the pendulum is in, the bob of the pendulum is in accelerated frame, we can take the pseudo force this side, which is ma to the left, right? So then the net force will be this side. What's the net force? Square root of m square a square plus m square g square, which we can write m square, you can take common from these two, and if you take it out, m into root over a square plus g square. The net force here, not net downward force, net force I am writing, because it is not downward completely, it is somewhat inclined. So the net force is equals to, we can take m, let's write this way directly. So the m into the g effective, this is the net force, which we got it as m into root over a square plus g square. Now m gets cancelled. So the g effective here, it is equals to square root of a square plus g square. A square plus g square. So which means if you take g also out, if you want, you can take g also out, divided by g square each term. So then g square, g will come out here, a square by g square plus 1 will come. Done. So if you write the total time period 2 pi into root over L by g effective, what is g effective? G into square root of a square by g square plus 1, which means here the time period has to be actually 2 pi into root over L by g, and there is some additional term in the denominator, which means again the denominator term is more, the time period decreases. So the time period decreases. So this is a fast time or time gain takes place. Time gain takes place in this scenario. Done? Clear? Sure. Good guys. Next, so let's go for the further. So this is about the concept of G effective. Hope you guys understood now. So let's take the oscillation of the simple pendulum in an electric field. Now consider this is a pendulum. Let's say if the electric field is upward, this is a pendulum of mass m which is placed in the electric field. So when the mass of the bob, we take it as a positive charge. This bob, we consider it as a charged particle. Which charge, sir? So very small positive charge. Okay. So this is very small positive charge. Mass of the bob as a charged particle. Okay. So the two positively charged particle. Considering bob as positively charged particle. Done? Chal. So here you know that the mg force acts downward. That's fine. If a charged particle, positively charged particle is placed in the electric field, so the electric force that acts on it will be QE. This you learn it in the second year. That means class 12th. The first chapter, electric charges and fields. If any positive charge placed in the electric field will experience a force of the charge into, let's say its charge is Q. This bob is having charge plus Q into that intense electric field magnitude. The magnitude of the electric field intensity, which is E. So now where is the net force? So the net downward force only we consider, which is mg. So the net downward force is equals to mg minus QE. mg minus QE. So the net downward force we write it as m into G effective, which is equals to mg minus QE. So let me do one thing. Let me cancel the mass part. So mass term, m into G effective is equals to m, take it common. So here G will be left. Here QE by G will be left. If there is no G term, QE by m will be left. Yes or no? There is no mass term in it. So if I took it out. So if you multiply it again, QE you will get. Done? Chal. So m gets cancelled. The G effective will be equals to G minus QE by m. G minus QE by m. Fine. This is a G effective. Now let's go for the time period. How do you write the time period? So 2 pi into root over L by G effective. In place of G effective, so G minus QE by m. So which means from the G value something you are getting subtracting. Something is getting subtracted. From the G value something is getting subtracted. That means overall G value decreases. That means the denominator value decreases. So if the denominator decreases, so the time period increases. So the time period increases means time loss takes place. If the time period increases means the time loss takes place. Loss in time. Understood? So here also I have explained. So if the time period is more, there is a time loss, slow time. In thermal properties of matter also I have explained you clearly. Right? Chalo. So this is the scenario. So if the electric field is placed down, what if the electric field is placed down? This is the fixed end, the pendulum. If the electric field E is downwards, so this is a positively charged bob with the charge Q. You know that the weight acts downward, mg, and then the electric force also acts downward, QE. Then net force will be equals to, that is m into G effective, net force is equals to QE plus mg. QE plus mg. Done. Chal. So m into G effective is equals to QE plus mg. So here I am taking it as QE plus So let's do one thing. So take m out. We'll cancel m on either side. Here if you take m out, so I can write g plus qe by m. Fine. So here m gets cancelled. So then g effective will be equals to g plus qe by m. G plus qe by m. Then the time period, what about the time period now? So the time period will become 2 pi into root over L by G effective. In place of G effective, I can write G into, so G plus QE by M. Actually in the denominator it has to be G, but along with G some more term is there, the two adding G plus something. So that means overall the denominator value increases. If the denominator increases, so the time period decreases. So if the time period decreases means gain in time. Here the time gain takes place. The second scenario. So you can take one more scenario also. What if electric field is applied towards right or left, sir? So that scenario also you can take. Let's say fixed end the pendulum. So if the electric field is applied to the right, then what happens? See here, this is a bob which is having the positive charge plus q. You know that the weight mg acts this side and the electric force QE acts this side, mg is down, so QE is right. So then the net force will be vector this one, so which is nothing but square root of QE square plus mg square. Done. Now so the net force I can write m into g effective is equals to square root of QE square, that means q square e square plus m square g square. Do one thing. So m into g effective is equals to, so I am taking m square common within the root, so then it becomes q square e square by g square, m square q square e square by m square plus, so this part, so m square g square by g square will be left here. Yeah. So then m, if you take it from the root, m if you take it from the root, so m into the g effective is equals to, so m taken out from the root, so then q square e square, let's write this way, g square plus q square e square by m square. Actually it has to be g, so then g square plus some other term is there. Again the denominator value increases, so the time period decreases. Time period decreases means the time gain takes place. Here also the time gain takes place. Understood, guys? Overall the denominator term increases. If the denominator term increases, the time period decreases, which means gain in time. Here also you can write that step, gain in time or time gain I can write. Understood, guys? Everyone? Done. Clear? Chalo. Hope you guys are understanding the simple pendulum concept. I am not taking any questions, particularly the previous year questions. So but I am explaining what kind of questions can be framed and how, on what concepts the questions can be framed, like this or this way the questions can be framed. In the next session I will take the complete questions. Here we will deal with the concepts. Okay, chalo. Effect of temperature on time period of a simple pendulum. This we already discussed it in detail in thermal properties of matter. So you know that when the temperature increases for the length based pendulums, okay, so if the temperature increases, the length increases. So if the length increases, the time period increases. If the length increases, the time period increases, because the time period is directly proportional to root L, right? The time period is directly proportional to root L. If the length increases, the time period increases. So the time period increases means loss in time. Loss in time. Yes. So if the temperature decreases, then the length decreases. Then so the time period decreases. So which means gain in time. This is that scenario. So the gain in time. So what's the loss or gain in time? What's the loss or gain in time? So the delta t, the change in time period, will be equals to half t alpha delta t. Did you guys remember? We learned it in the thermal properties of matter. Thermal properties of matter or thermal properties of matter only. So half t alpha delta t. So this is the original time period. Original time period. And then this is a change in time period. Change in time period. And then what is alpha? So the coefficient of thermal expansion. The coefficient of thermal expansion or linear thermal expansion. And then the delta T eta is a change in temperature. This is change in temperature. So then what is the loss or gain in time? So the delta T formula also we have seen. So this is a loss or gain in time, which is equals to, so the delta T by T into in the given time. Okay. So already we solved the questions related to this. If you want, you can refer to that lecture, the first lecture of the thermal properties of matter, or mechanical, I have explained it in mechanical properties of solids, I guess. So check it in those two. Yes, mechanical properties of solids, I guess. So this is a loss in time. Time loss or gain. Gain in time or loss in time. So that's how you can calculate it. Clear, guys? Understood the concept? Sure. Now the angular S.H.M. See, we know that in the case of linear terms, we expressed any force as first F is equals to minus kx after displacing the body from its equilibrium position. So then represent the force, net force acting on the body in the form of F is equals to minus kx. So then the time period will be equals to 2 pi into root over L by G. This is for any body which is making the S.H.M, the two linear. Now let's go back to the angular terms. Let's go to the angular part. Shall. So just compare. So in place of force, what do we have in the angular? Torque. So which is equals to, let it be K, and in place of linear displacement we have the angular displacement theta. That's it. So you have to represent the net torque acting on the body after displacing it from the mean position. So with F as tau is equals to minus k theta. Then so the time period will come out to be 2 pi is a constant into root over, in place of L, sorry, this is for the simple pendulum, right? This for any S.H.M, this is the formula, root over m by k. So now in place of m, what do we write? The moment of inertia. Yes or no? Analogy. Did you remember the analogy between the linear terms and the angular terms? So in place of k, k only. Understood? So any body in the angular S.H.M means the body which is rotating. Okay. So there the torque comes into the action. Done. So if the torque comes into the action, so displace the body from its mean position, then represent the net torque acting on the body as minus k theta. So in place of that k, so in place of this k, just substitute whatever you got in the question. So we will see the question based on that, so that you will understand clearly. So just note this down. So let's go for the physical pendulum. See, the physical pendulum, what we do is, this is also called the compound pendulum. The physical pendulum is also called the compound pendulum, where the entire object is pivoted at one point and it will be rotated about the pivoted point. If you displace it from the mean position, what it does, slight displacement, then it does the S.H.M. The whole body does S.H.M. That's called the physical pendulum. Okay, there we took the string length, there is a length of string, right, and then bob of mass m is attached. Then if you displace the bob of mass m, slight displacement x is given, then what it does, S.H.M, simple harmonic motion. That's a linear one. Now the whole body is pivoted at one point. Now you displace it by the theta, so then it does S.H.M, the whole body does S.H.M. Okay, that's a physical pendulum, or which is also called the compound pendulum. It is also called as the compound pendulum. Done? Clear? Chal. Now let's go further. Let me take any body. Consider this is a body which is pivoted here. Now let's say this is a body which is pivoted. Now you displaced it by some angular displacement theta from here to here. So the body is displaced by an angular displacement theta. Alright, chal. So this is a center of gravity. Okay, this is a point center of gravity or center of mass, you can consider. So then here the center of gravity, let's say this is a point G, this is a point G. Now, so when the body is, this is a mean position, now body is displaced slightly from the mean position. Now represent the net torque acting on the body. Here not net force, here we take the net torque acting on the body. So how do we represent the net torque? Here when the body is here, I can write like there are two forces which are acting. So one is along its axis of rotation. What is that force? If it is the theta, so then I can take this angle also will become theta. So then this is going to be mg cos theta. Its overall weight comes out to be mg, m into g. So here it is going to be mg cos theta. This is angle theta. This is mg cos theta, and this is going to be mg sin theta. Done? Chal. So then this is a length L. Let's say the center of gravity is at a length L. Now this will be the perpendicular one. Yes or no? The torque is due to only mg sin theta. What is the torque formula? The r cross f, torque is equals to r cross f, right? So here this angle is going to be 90 degrees. We can simply write r into f. So what is r? Mg sin theta. The torque will be there due to only the perpendicular force. So due to this one there will be no torque. Mg cos theta is along the axis of rotation. If any force is along the axis of rotation, the torque due to that force is 0. You already know, right? The torque due to, I'll write here, the torque due to mg cos theta is 0. Why? Because it is passing through the axis of rotation. Passing through axis of rotation. Done, guys? Chalo. Now, so tau is equals to mg sin theta. So here into what is the length, distance, r. R is L. So here we consider this theta as very, very small, the slight displacement. So here the slight angular displacement, which is nothing but the theta is very, very small. The theta is very, very small. If the theta is very, very small, the sin theta tends to theta. Done. So in place of this sin theta, I am writing mg theta into L. Now if you see that the angular displacement is right side and the net torquing is acting towards left, so I can write this as the tau is equals to minus mgl sin theta minus mgl theta, not sin theta, theta. Done. So if you compare it with, so you can write here, the torque is equals to, we got minus mgl into theta. So if you compare it with, the torque is equals to minus k theta. We have to represent any force in the form of torque is equals to minus k theta. This is in the angular term, right? Chal. So now here I can write, so the k is nothing but mgl. The k value we got it as mgl. So then what's the time period? 2 pi into root over, so the I, moment of inertia, by, so the k, what's the k value? Simply mgl. The time period t is equals to I by, in this particular case we got the k value as mgl. That's it. Done, everyone. So here, so let me write that formula again here. So the time period t is equals to 2 pi into root over I by mgl. So where I is the moment of inertia of the body about its pivoted point. So what's I? I is a moment of inertia, MOI, of body about given pivoted point. So then m is the mass of the body, g is the acceleration due to gravity, L is the center of gravity. The length of the center of gravity. Okay, so that's it. You have to remember these things in the case of physical pendulum. Understood, guys? Everyone clear? So I can give one question here. So let's say if a uniform rod of length L is pivoted at its one end, and find the time period of it. The question is, if a uniform rod of length L is pivoted at its one end, so then find the time period. Find time period of it. If it's given slight displacement theta, so then what's the time period of it? So they are saying that this is a fixed point, and then uniform rod of length L is on mass m is hanged from this fixed end. So now it is pivoted here. From the pivoted point, it is given some angular displacement. That means the object will move this way. So the angular displacement theta. Done. Chalo. So then I can write, so the torque is equal, time period formula in this particular case is I by mgl. So you know that the moment of inertia from one end about the pivoted point means this point. The amount of moment of inertia of an rod about its end is going to be ml square by 12. Sorry, ml square by 3. From its center, ml square by 12. So here it is ml square by 3. So then the time period is equals to 2 pi into, so the moment of inertia is ml square by 3 into mgl. So the length is, let it be L. Done. So here L we have to take, or L by 2. So its center of gravity will be at a distance of L by 2, right? So consider this as L by 2, guys. So here you have to substitute L by 2. Understood? That is important. So here t is equals to 2 pi into root over, so this 2 will go up, 2 m cancel, 1l cancel, so 2 by 3, 2l by 1l is left, right? 2l by 3g, right? That's it. Yeah, so 2l by 3g. This is a concept. Understood, everyone? Got it? So I'll give one question for the homework. Consider this question as the homework. Let's say this is a fixed end, and then from this point a circular ring is placed. This is a circular ring is placed like this. Now if you give the small displacement to this one, so what will be the time period of it? So find the time period of it. This is a pivoted point. This point is pivoted. So you gave small displacement, then it becomes a physical pendulum. You have to find the time period. Let's say its radius is r. So find the time period of it. Find the time period of it. Clear? Understood, guys? Everyone? Chal. So that's it for today. So in the next session, we'll see the oscillation of the floating body, and then so the next concept, that is one more thing that is left, is S.H.M of a body in a tunnel along any chord of the earth. So the simple concept. So these two concepts we will see it in the next session. So with that, the total S.H.M will be done. I'll take more questions in the next session first, then I'll go for the remaining topics. So chalo guys, we'll meet in the tomorrow's class. Till then, keep studying. All the very best. Bye. Take care.